So good morning, everyone. Thank you so much for joining us. My name is Avril Lavasser. I'm the program manager for the Stanford Building Decarbonization Learning Accelerator. So for those of you who haven't seen our materials, we create teaching materials for professors and other educators to use to teach building decarbonization in higher education. All our materials are free and available online. We also host events such as this one to try to get more information out there. So today we are so excited to be joined by Bruce King. Bruce has been collaborating with us for a couple of years now and is the brain behind some of our embodied carbon materials. So we're excited that he'll be able to speak with you today. Bruce King is a recovering structural engineer who, after 45 years designing buildings of all types, is working to turn the building industry from a climate problem to a climate solution. He's the author of 5 books on low carbon building, the Marin County Low-Carbon Concrete Code, and the ASTM standard for earthen construction. He's also the founder and director of the BuildWell Project, offering free video and other online resources on climate-friendly building. So thank you so much for joining us, Bruce, and I'll turn it over to you.
Thank you. And thank you all for coming. Good morning and welcome. Yeah, I've sort of got into a new angle on buildings, as has Avril and the whole BDLA project, and tell you a little bit about embodied carbon, but I like to start with a very fast review of the basics. It's been about 500,000 years that our species has evolved away from the primate family tree, and during that time, the CO2 has been pretty steady, banging around between 200 and 300 parts per million. And in particular, for the last 40,000 years, it's been especially steady. It's been a very stable level of CO2 and a relatively stable climate, during which time we evolved. Everything from the oldest relics of human beings that we have, the cave paintings in France and Spain, through all of history up to the moon landing and the internet and you and I talking by all these fancy devices right now, all through a very stable climate. And of course, we've sort of bucked that up a bit by burning fossil fuels, and they're up through the roof now. Last I checked, which was yesterday at Mauna Kea, 424 parts per million. Here's the interesting thing, is if we were to stop burning fossil fuels on a dime tomorrow, they would still go up. They would still be going up, largely because of the methane being released in the Arctic now, but a number of factors. Some we probably haven't even perceived yet. We don't just need to stop burning them. We need to start drawing it down. Not just getting to zero, it's bringing it back and putting the carbon somewhere other than in the sky. Bringing it home. But where? Well, right now, by default, the ocean is doing a lot of the heavy lifting. It's absorbed about 1/4 of the emissions that we put up since the dawn of the Industrial Revolution, to disastrous effect for the animals and plants in the ocean, because it's changed the acidity level. It dissolves the carbon of the corals and other calcareous shellfish creatures in the ocean. I don't think we fully understand what the effects are so far, but so far we know they're bad. The forests have been doing a lot too. About 1/3 of the emissions gathered up by the forest. Unfortunately, we're cutting down all the forest, so they can't do so much. And if you cut down an old growth tree and replace it with a seedling, you can say, yes, we've reforested, but the seedling can't possibly absorb carbon at the rate that the old trees do. So that's not working out so well. Where can we put carbon? If we can draw it out of the sky somehow, and we'll talk about that, there's kind of 3 places. One of them is soil. And it's a really good place. And you probably know people who work in regenerative or organic agriculture, sustainable agriculture. That's a whole world in itself, but it shows an enormous amount of promise to store carbon in the soils in a way that restores their fecundity, recarbonizing the soil that we have decarbonized over the last 100 years. And then there's underground. If you can gather up the CO2 and pump it underground, there's lots of places apparently where you could store it and it won't come seeping back up to the surface. That may or may not actually be a plausible idea, but the funny thing is that hear our friends from the fossil fuel industry step up and tell us all about it and how great it is. Because in fact, we as American taxpayers are paying the oil companies to gather CO2, pump it underground, and store it apparently permanently. And what they're also doing is recharging their oil fields so that they're getting more oil and gas out of the deal. So they're getting lots of good PR for being climate champions and storing the carbon and also getting more of their own product out of the deal. Pretty much of a mixed bag, as far as I can tell. And then there's cities and buildings and infrastructure, not just buildings, but the highways and bridges and ports and tunnels that we build. That's a big repository. There's a lot of stuff there, especially since we're building the equivalent of another New York City on Earth every month right now. I first heard that a few years ago, and I didn't believe it. I don't see that happening. And probably you don't either, because probably you're in the USA. But if you've ever spent time in the Southern Hemisphere or in Asia, you have seen it. I've been in these three cities in the last few years, all of which were jaw-dropping in the level of construction, just the frenetic level of construction. Cairo, for example, is almost all concrete and brick, and it's gone from 5 million to 20 million people in a couple of decades, and driving all over the city. And I spent a lot of time going all over the city. A whole lot of new buildings and not a shred of insulation. A lot of construction going on, not of high quality from our standards. Buildings account for about 40% of global emissions. That's the generally agreed upon number. How would you break that down? Well, most of that is from the operating emissions, from keeping the lights and the air conditioning on and keeping the building going. And over the lifetime of a building, that adds up to a lot, especially when you build basically really crappy buildings. They're leaky and they're not insulated and they're radiating heat and invisible carbon emissions into the air all the time. Many of you on the call are probably familiar with all this stuff. So that's kind of a problem. Then there's the embodied emissions. There's these two phases. With anything you build, there's two phases. There's you build it, and there's whatever embodied emissions, that is, whatever emissions came from the supply chain upstream from before you actually put the building together. And then there's the operating emissions. And over the lifetime of most buildings, 30, 40, 60, 100 years, the operating emissions are far, far bigger in aggregate than those embodied emissions are. And that's why the green building world for the last 30 years that I've been involved is focused on the operating emissions, insulate better, close up the air leaks, better air conditioning systems, better lighting systems, and so on. And we've made a lot of progress. It's pretty cool. We've reduced them down to far less, sometimes even to zero. Great success, and you can measure it. Here in North America, we have way more building area than we did a few decades ago, and yet the total emissions from the building sector are down. Cool. But now we go back and look at those embodied emissions that we weren't paying very much attention to up until recently. And there's a couple of things that stand out there, mainly that they're up in the air first. They're up in the air for a long time, and they have what we've come to think of as a time value. It's a little bit like the time value of money, but different. But they're up in the air. Your effect on the climate is not just how much carbon you put up there, but how long it's there cooking away. The embodied emissions are up there from the very beginning, cooking away before anybody ever moves into your building. So they have an exacerbated, outsized value. And they're bigger than we thought they were. And they're happening right now. We realize that we can't be thinking in terms of 60 or 80 or 100 years like the lifetime of the building so much as the next 10 or 20 years, because we're in climate emergency. And in that context, the whole arithmetic switches all around, and the most of your impact from something you build this year will be from the materials and products you chose to build with, whether it's a remodel, whether it's a new building, whether it's a highway, whatever. We're figuring this out as we go, and this is very clear. The impact is from the stuff in the value chain, the supply chain upstream from where you got your materials. But it works both ways. Here's the good news. If you can build with carbon, you can suck the carbon out of the air somehow. and build with it. And that's that much less carbon in the air from the very beginning. And it also has a time value that's working in your favor. So we could turn something around here and actually be doing a climate benefit by building. First and foremost is to fix what we already have. We've built a lot of lousy buildings in the world. And they're out there bleeding energy like crazy, bleeding carbon like crazy. And they need to be fixed. The glass-walled office buildings that fill every city in the world now, and just the bad housing that's done everywhere. Then to just be climate conscious of the materials we use and the energy usage to operate, to become more aware of this stuff. Well, as far as materials go, as far as embodied carbon goes, there's two basic categories: minerals and plants. Minerals are mostly metals and concrete. Glass is there too, and they all add up to something, but really the big ones are concrete and steel. Concrete is 8% of global emissions. Steel accounts for 7%, and about half of the steel goes into buildings. So, pardon me, that's a big old chunk right there that we can pay attention to and focus on and maybe reduce. And in fact, we can reduce. Steel is already working at a very high recycling. I see people saying, well, we just have to specify a minimum 98% recycled content, which is fine, but that's what the industry's been doing for decades now, just from pure economics, because it's easier and cheaper for them to harvest the steel from the flow of materials within our industrial ecosystem than it is to go dig up more ore somewhere and harvest more iron and so on. They're already recycling at a very high rate, purely for economic reasons. And even so, when they do, there's a lot of energy involved in gathering and cleaning and sorting it and then melting it again. Copper is a particularly interesting one. It's not a huge volume as far as compared to steel, but it's not fungible. You can't conduct electricity. You can't transmit power over distance with anything but copper. You can do it with aluminum, but that's no big advantage. There's all sorts of problems with aluminum, both climate-wise and otherwise. In copper, we go crazy for copper. When we first discovered it 4,000 or 5,000 years ago on the island of Cyprus, same name as the metal, our ancestors found it in almost pure metal form lying around on the ground by a geological accident for that island. And that was the birth of the metal age. So they could harvest, they could mine 100% pure copper. Now we dig pits like this that you see for ore that it's maybe 0.2% copper. And the rest of it is just spoils. They dig a pit this big, and there's lots sorts of them all over the world. And the actual amount of copper that we retrieve from it is less than would fill that lowest level down there. But we need it, so that's what we do. And we devastate entire ecosystems, whole islands on Papua New Guinea, whole human cultures to get the copper that we need. We're going to have to get a lot better at recycling, and then we're going to have to use clean energy to recycle. And that's going to be hydrogen. It's almost surely going to be hydrogen. It's not an energy source. Anybody's paying attention, you know, hydrogen is an energy source. It's a storage medium. It's a battery. Right now, if you buy hydrogen on the industrial market, you're buying a gas that was made with fossil fuels, so-called black hydrogen or gray hydrogen. If we start to make it with renewable energy, then we can call it green hydrogen, and it's a clean footprint. And you can harvest a whole bunch of wind energy in West Texas and send it up to Chicago as hydrogen to keep Chicago warm in the winter, that sort of thing. And here, our friends from the fossil fuel industry show up again because they're working on this too. There's money to be made, and they're figuring out how to make hydrogen. Good for them. We'll get back to that. Then there's concrete. Kind of a big target in a lot of people's minds because everybody uses it. It's part of almost every building project, and it has a huge footprint. So let's be clear what concrete is. It's just a bunch of little rocks glued together into a bigger rock. That's all that it is. What kind of glue you use has changed over time. Right now we use Portland cement, baked limestone. Cook it at 2,600 degrees Fahrenheit, mix in a little clay and gypsum, and you got Portland cement. It was invented exactly 200 years ago in Portland, England. Clay was the original binder by which we made the original concrete. Earthen construction is clay concrete. And in fact, if you look at it, all building is earthen building in the sense that it's all stuff that we took out of the ground. You're sitting on an earthen chair right now. You're sitting in an earthen building. You got here in an earthen vehicle, et cetera, et cetera, et cetera. Everything is something we took out of the ground. And it's just a question of how much we processed it in order to take the form of carpeting or concrete or steel or lights. And really the whole secret to low embodied carbon building materials anyway and products is simplifying and shortening that supply chain. So you don't have to mess with it too much. You don't have to bake it or bend it or pressurize it to get the useful product that you want. Plain old clay construction itself is having a comeback. I work with a lot of people in a lot of places working with clay construction. It's various forms, rammed earth, adobe, and in fact, the highest prize in architecture was just given a couple of years ago to Francis Carré out of Africa, who's been doing wonderful stuff with natural building materials like clay and natural plants from where he lives, and doing beautiful, lovely, inventive stuff. The Romans figured out that certain kinds of soils, volcanic soils like you found around Mount Vesuvius, could be mixed with their lime plasters that had been around already for millennia. And they got this really high quality concrete by which they made the Pantheon and other buildings. Higher quality in many ways than the concrete we use today. And we use a lot. We make about 10 billion tons of concrete on Earth every year. When I heard that number, I thought, okay, 10 billion tons. Yeah, that's a lot of concrete. You know, we hear big numbers all the time. Your eyes kind of glaze over now. Okay, great. Well, how much is that? Well, 1 ton of concrete makes a cube. Yes, it's 29 inches high. It's desk height. That's a ton of concrete there. 10 billion tons makes a cube. That's a mile on a side, 5 times the height of the Eiffel Tower. That's how much concrete we're mixing and placing somewhere on Earth, typically in Asia and the Southern Hemisphere now. For concrete, pound for pound, it's a very low carbon material. But you make a cubic mile of something, you're going to have an impact no matter what. And so concrete accounts for 8% of global emissions. If it were a country, the concrete industry would be 3rd on Earth, behind only the United States and China. So we're working to reduce those emissions. As a $600 billion industry, the concrete industry is moving amazingly fast to reduce their emissions. And there's so much talk, so much innovation, which is cool. And they're really working on it. But they can do even better than that. They can make their concrete out of carbon. And there's all sorts of startups, all sorts of outfits in various stages of maturity, bringing carbon-based concrete to the market. That'd be a whole hour-long sideshow if I got into all of that, but it's exciting. There's a lot happening, and we can soon be making, in fact, some cases people are making net carbon positive concrete that you pour it there and you have net taken carbon out of the air and put it in that slab or sidewalk or whatever it was you were making. Soon we'll be doing that routinely. Gather the emissions, gather the CO2 out of the cement plant, the power plant, some industrial plant where the flue gas is rich with CO2, gather and turn it into artificial limestone and other things, CO2 that we can use in building products. And so we can get bricks and concrete, and all sorts of things made with carbon that we retrieve from the sky. Typically with machines like this, you've seen pictures like this, big ungainly fan-like things. Maybe like me, you look at that, you know, there must got to be an easier way. Like, haven't you ever heard of forests and fields where the plants are just doing all the work with solar energy and they're harvesting the carbon? Why don't we just let them do all the work? Which I'm all in favor of letting somebody else do all the work. But the plants can't deliver us liquid or gaseous CO2 as we need to do quite a lot of other things. They can't retrieve it as fast as we might want. So it's going to be a mix of both, these ungainly machines and the plants. Well, how do you get the plants to do the work? How do you ask the plants to do the work? First of all, it's just interesting to note that as the straw bale construction thing came about 30 years ago, or now hemp, is coming on really strong, and I'll talk about them both. People go, well, we can't build planes because it's just, it doesn't sound right, and everybody just starts thinking about mold, thinking about fire. And yet we have a lot of experience building with cellulose. It's not the first time we've ever done this. We've been building with wood for a long time. And yeah, it does rot and it does burn, but you can also do really cool stuff with it. And we love wood. Everybody loves wood. It's a wonderful texture feeling to be around. And we gotten the hang of how to make it fire at least resistant and bug resistant and so on. Started with just simple stuff. This is a replicate of a Miwok village here in coastal California where I am. And for them, it was pretty simple. It was a mild climate. You just picked up slabs of redwood bark and leaned them on each other, and you had a shelter from the rain and the sun. That's all you needed. Once we had metals, we could be a little more fancy about how we treated wood and build log cabins. And then around about World War II, we invented plywood, largely to make the famous PT boats, which are the fastest and deadliest things on the water, and were a part of the success in the war in the Pacific. They can zoom on in there and shoot the bad guys and zoom back out. And thus was born the plywood industry, which changed everything in so many ways. And industrial milled lumber. We learned how to process trees into rectangular shapes that were a lot easier to work with, and we went to town. And forests became this wood framed housing all over North America, and more now in Europe as well. And yes, it'll burn. I took this picture in Santa Rosa after the fire there 4 years ago. And sometimes you can get a fire, and we're going to be getting more and more of these fires that come in from the wildlands into urban areas, and they can't be stopped. They'll burn anything. They'll destroy a concrete building. So that's a whole subject in itself. But wood will burn, yes, but we know how to work with it in ways that it will be less likely to burn. We took the plywood concept and then started making glued laminated beams and artificial joists, side joists, and so on. And now it's reached its sort of pinnacle with mass timber. As a structural engineer, I can tell you that up until a couple of decades ago, if you wanted to go more than 5-10 stories, you had to use steel and concrete. That was the only way we knew how to build structures that tall. Not really, because of course the Japanese had done it with wood for centuries, and many people had done it with masonry for a very long time, thousands of years. But earthquakes tend to knock things down, or fires tend to burn things, and so on. In any case, we could build within cities tall and elaborate buildings and really cool buildings. This is a train station in Seville, Spain, with wood, because we could basically take the trees apart and cut them up and glue them back together in all sorts of different ways that were never possible before. Great. And mass timber's the big deal now, and you read about it everywhere. Sometimes because it's just cheaper and faster than other forms of construction. So you get simple, ordinary office buildings that they chose wood because it went up faster. And sometimes people choose mass timber because you can do cool stuff that looks cool, and people like to be in it, and it's fun. And so it's kind of taken over, and it's become this poster child for climate-friendly building. Needless to say, the timber industry is pushing that really hard. We're storing carbon. Look at this. You're making it out of wood. Which can be true and often isn't true, because sometimes the wood is harvested from a operation like this. This is a certified sustainably harvested forest under the banner of SFI, the standard that the wood industry itself put together. And though SFI is better than nothing, it's obviously not all that great. So your takeaway as far as this goes is use FSC certified lumber, Forest Stewardship Council, been around for a long time. Everything's lumpy and imperfect, and boy, it gets complicated if you want to look into it really deeply, but FSC certified lumber is where you want to go. This forest is an FSC certified forest that has been logged 6 times since World War II. So, we can get along and let the forest be and be healthy and get some lumber out of it. then there's straw. We grow food. We grow rice, wheat, corn, oats, barley, etc. We harvest the seed from the top of this grassy plant, and then the stalk is left over. That's the straw that we bale up and don't really have that many things to do with, or at least we didn't until recently. If you took all the straw in the world and bundled it up to the density of a straw bale, you would get a cube 1.6 miles on a side, far bigger even than the concrete. 2 billion tons of straw every year. And so far, we're mostly just burning, which isn't so great in a lot of ways. Straw bale construction was the beginning of using straw, just other than just stuffing it into walls for insulation, which people have been doing for a long time. But European settlers coming into western Nebraska, the sand hills, had no stone or wood or even sod. They couldn't even build sod houses because it was this sandy soil that I've been there, and your foot sinks into the ground every step you take. Beautiful grassy hills. But they had the newly powered baling machines, horse-powered baling machines, and they put together bales of straw, stacked them up, and put a roof on it, and there you go. Straw bale construction was born. And there are several dozens of these structures from 100, 120 years ago that are still there. And now, straw bale buildings taken over the world, another American invention. Hey, America, like democracy and jazz, straw bale building has spread all over the world, surely on its own appeal and merit, without anybody particularly trying to, which is great. But you're not going to build another New York City every month out of bales of straw. So how's that going to work? It's not going to be like this. It's going to be some other way. 2 billion tons of straw. You could replace all the insulation materials that we currently use on Earth with straw-based insulation. We've got the industry going to make straw insulation. If you harvested all the straw and turned it into building products, the carbon you store would negate all the emissions from India. It's pretty large volume, pretty large opportunity. And here it comes, straw 2.0. Don't just try to use bales and stack them up in, funky hippies in the woods bale building parties in Mendocino County. Do something that can work in an urban context where people don't have this much thickness for their walls. They have to constrain it a bit. And the Europeans in particular have taken the ball and are running with it and innovating with straw panels, like you see in the picture. Straw Blocks is a company here in California that's gurgling along and will be here soon. Panels, blown insulation products. The French in particular are doing a lot with straw bale, a lot of innovation and just a lot of volume of building. It's extraordinary what the French are doing, but also the Australians, the Kiwis. Straw building products are coming on strong. And likewise, hemp is coming. It's a bespoke crop in that you have to plant the hemp to harvest the hemp. When you've harvested the hemp and gotten the oils and seeds that you might use for food or medicine or clothing, what's left after you've harvested all the high quality fibers and seeds and everything is the hurd, which turns out to be just the stuff we want in the building industry because it's a really high quality fiber. There's a reason why our ancestors used hemp rope to sail the seas, because it lasted longer and it was stronger and it could handle all the wetting and drying that happens at sea. It was the highest quality fiber. And now we've taken it, and the technology of using hemp in construction is exploding. Basically, you mix it with some lime plaster, make blocks out of it, or pump it into walls, spray it into walls. And this is a building in England, Marks and Spencer store that's been there now for at least 10 years. Big success for thermal performance and for construction. So hemp's coming on strong, big in Europe, just starting to arrive in America, although arriving big time. Likewise, bamboo is another crop building material that we have a lot of history with, thousands of years in the tropics, with building with bamboo and doing all sorts of things with bamboo. And it's enjoying a resurgence now with elaborate exotic buildings like you see here. A few architects in Central America and the South Pacific just doing beautiful, beautiful, wonderful stuff. Not what you would call affordable housing, but nonetheless wonderful work with bamboo. But many people started thinking, well, how could we take this very high quality fiber, which is what bamboo is, extremely strong, stronger than hemp, and work with it? It's this lumpy, irregular grass. How do how do you build a wall with that? How do you build a roof with that? Well, you squish it. You basically squish it. And there's a company right here in California, up in Santa Rosa, Bamcor, figured out how to take the bamboo, smush it down, glue it back together into panels, and make very super energy efficient houses, because you don't need studs anymore, which are conductors of electricity that transmit heat in and out. The bugaboo of mechanical engineers and energy analysts everywhere. You just have straw panels because they're so strong you don't need the studs. Cool technology. Well, here's where I admit that I lied to you, saying there's only two kinds of building materials, minerals and plants. There's actually a third, which doesn't really belong in any category. We've all had metals and glass for centuries. They've been around for a long time, and we've been working with both of those things for a really long time. Wood's been around for a long time. Concrete's been around for 10,000 years in one form and another. So these things really aren't new. We've just got newer and better versions of them. Even oil we've been using in our buildings and other things for a very long time, because in places like Santa Barbara coastline, where it seeps out of the ground and there's whole little bluffs of tar in Carpinteria, where the Chumash Indians would use it to caulk their canoes, and they could go out to the Channel Islands. So all this stuff's been around. What hasn't been around is plastic, petrochemical polymers. If you haven't seen the movie The Graduate, go see the movie The Graduate, then you'll get the joke here. Started making plastic, again, around World War II, a little before, but now we've gone wild. And I imagine most of you are at least roughly familiar with, well, the disaster that plastic is, and also the incredible benefit it is. I mean, it's part of our lives. You can't get away from it. It's providing so much utility. You're wearing it on your body right now. You got here in a plastic vehicle. It had some metal and a lot of plastic. Your food was provided to you with all sorts of plastic polymers, et cetera, et cetera, et cetera. Look around the room and you'll probably see 10 or 15 different polymers if you look. It's everywhere. We use it for everything. And it's a disaster as it gets back into the ocean, and creatures at every size and scale mistake bits of plastic for jellyfish or food in one way or another, and causes terrible damage. If we could ever get it back out of the ocean, it's going to look like this. It doesn't look like a plastic bag anymore. It quickly turns into lots of little bits, smaller and smaller bits, as it gets banged around in the waves and the sun. If we could somehow miraculously harvest it all tomorrow and brought it ashore, what would we do with it? Well, we're what we do with it. We're the construction industry. We use far more physical stuff than any other industry by an order of magnitude. We can turn it into insulation and paneling and concrete and all sorts of stuff. We're the ones who can be the repository for the plastic that we got back out of the ocean and out of the soil and everywhere else. And this is where we're going to start relying more and more on our friends in the microbial kingdom, just meaning smaller than you can see with your eye. They're starting to show up all over the place. Food, shelter, and clothing. We're already doing food and clothing. Fabrics made with microbial life forms of one form or another. And food, artificial meat, is already out there. Burger King sells Impossible Burgers. You might turn your nose up at it because you're vegan and you don't want to eat meat and so on, but the world wants to eat meat. The numbers are pretty overwhelmingly there. People want the protein. And if we can do that with microbes rather than cows and pigs in horrific conditions and so on, it looks pretty cool to me. And likewise, we're using it in buildings, and it's already starting to show up. Ginger Grigir in North Carolina, studied the way termites chew up the clay soils around them and with their saliva turn it into concrete, and invented biomason. And she's making bricks now and pavings and all sorts of things. And biomason is going gangbusters. They've been around for at least 10 years now. Likewise, the folks down in San Diego at Occam Works are using mushrooms, fungi, to make concrete. It's structural concrete. Ecovative has been making insulation now for some years for various purposes. And people are starting to make algal concrete using microbial life to bind little rocks together into structural concrete. Just the beginning on that one, but it's an exciting beginning. We'll be able to use microbes with ordinary earth, clay soils, to make not just plasters and floors and so on, but actual structure. And I'm particularly excited about the microbes for a particular reason. We have all these different plant-based building products and many more coming. But when you run some numbers, and this is, well, I'll show you here as a result of a bunch of different studies, so I couldn't properly annotate this like an academic paper, but generally this is what we've seen, is that if you look at how much carbon can we gather with plants, how much carbon can we harvest from the air and turn into usable carbon per hectare per year, you start to see a comparison. Softwood forest, 2 to 4 tons. Straw, maybe a little more. Hemp, quite a lot more. Woo, a little jump, order of magnitude jump. And likewise, bamboo, even better than that. You can get, they grow really fast. They suck up the carbon really fast, and you can use them to build with a structure and insulation and sheathing and all sorts of things using carbon we got from the sky. But algae is through the roof. Algae, bacteria, fungi, these guys really eat it up big time. And we're only beginning to see how we might enlist the partnership of the little ones to pull carbon from the air and turn it into our buildings. And here's where our friends in the oil industry come back into the picture. Just as your body has a circulatory system that so amazingly and magnificently moves the blood around and gets oxygen to all the muscles and does all the things that it does, so likewise, we already have a circulatory system on Earth that's moving oil, coal, and gas around to serve our many needs. That's plastics and fuel and all the things we do that all seemed like such a great idea at the time, but it's turning out to have all these disastrous results, which you and I are trying to clean up now. And the oil industry is the one that built all this and is running it. And they're the ones who are going to be able to move carbon and hydrogen around as we develop them and have a carbon and hydrogen-based economy. And needless to say, AI will have a big role to play in all of this. It's already showing up in all sorts of ways in the construction industry. Again, a whole other topic for a talk. Not just outright robots on a job site kind of thing, though there's that, but just helping us do things that previously were so difficult or cumbersome, and now the AI can just do it like a flash. So some exciting stuff coming about. But if I leave you with anything, I just want to say that zero really isn't the goal. Getting to zero is what everybody talks about, and a lot of it's greenwash, of course. We got to just keep going. Aim at zero, but just keep going and go beyond zero to where we're storing carbon. Imagine a race. Not like a race like gritted teeth and people angry at each other and maybe cheating and pushing, but a happy, joyful thing like beta breakers, where people are in costumes, really having a good time, they're laughing. It's a party. Imagine a race where the whole industry, everybody's racing to who can store the most carbon in their products, in their work, an architect's office, a concrete plant, a building product manufacturer. Everybody's, instead of trying to comply with a whole bunch of new rules, and a whole bunch of new rules are being written right now at every level that are going to affect us all. Instead of just having a bunch more rules, that's a lousy way to go about it. It's the first step, but it's a lousy way. What if there was money on the table for you to store carbon in your work, whatever it might be, and everybody was racing joyfully to store carbon in what they did? That's the goal. I leave it at that. My recent book with Chris Magwood, you see in the upper left there, covers a lot of this stuff and more. And with our BuildWell project, we're starting to make videos and teaching slide decks along with the Stanford Building Decarbonization Project to get it to the students. And I'll stop the share. Right? Should I stop the share?
You can just leave it up. Yeah.
I'll leave it up. Okay.
Amazing. Thank you so much, Bruce. That was such a great presentation. We have some time left for questions. So for those of you on the call, if you want to put your question into the Q&A or the chat, or if you'd like, we can unmute and ask the question directly if you prefer. So please feel free to go ahead and ask any questions. Maybe I'll kick it off with a question to get it going. So Bruce, I'm interested, what's the material that you're most excited about right now? What do you think has the most potential to really, break off and become the next big thing?
There's no single one. The single category is concrete, but that's an amalgam of all sorts of materials in people. And in fact, I'd really actually answer that by, it's people. It comes down to people. We keep thinking about technology and new products, and there's lots of new products, and there's going to be lots of new tech, but it's people. We're part of an industry that is very conservative for good reason, and tends to keep doing the same thing. If we can all learn to keep an open mind and start thinking beyond the boxes that we're in, even as students who are already being herded into a box. And I know that a lot of people like Stanford University is trying to break that and open up the walls and have mechanical and structural engineers talk to each other, and landscape people and concrete guys talk to each other, and so on. But break the habits of the industry. That's the most important thing that we can do. That's the most exciting thing. There's lots of exciting materials. Hemp products, bamboo products, straw products, microbial, everything. There's just a ton that's going to be happening there, but it's never going to get any purchase if we don't start looking around and changing the way we go about things. That's the hard part, but it's also the exciting part.
Nice. Awesome. Thank you. Another thing I was curious about, I've seen a few new technologies where there's carbon neutral concrete, so injecting carbon back into concrete and things like that. But I've heard some skepticism about sort of the carbon neutral claims. Could you maybe talk a bit more about your thoughts on those kinds of products and if those are promising?
Well, there are a lot of really promising products out there, and there's always going to be a bit of greenwashing here and there. I haven't seen anything particularly egregious, and partly because you can't lie. You get caught because we now have an accounting system. We're still refining it and perfecting it, but EPDs, environmental product declarations, are the new coin of the realm. And if I come to you with my new carbon injection for concrete, or with my new straw-based panel, or whatever, some kind of product, and I say it's going to store this much carbon per ton that you use or per dollar you spend, you have to back it up. We already have a system in place that everybody's agreed on. We have to back it up with an EPD, an independently certified process by which we do the accounting and say, okay, you burn this much fuel in your process, you use this many chemicals, your suppliers, and so we look at all that stuff, and then we can say reliably, yes, this is your carbon footprint, and is it in fact positive? You're storing carbon. We can verify that. And so there are always flaws and lumps and little hiccups because we're still working it out as we go along, but we're not in the dark, so we know. And so if somebody claims to be storing carbon, you can ask to see the EPD and do the math yourself. And so fortunately, there's a back check on all that. There's always going to be lots of greenwashing. I don't know. It's nowhere near as important as the fact that, like, Chase Bank and BlackRock just bowed out of the Climate 100 agreement. There's levers being pulled a lot higher than you and me, but I can't do anything about that. So this is where I'm working with the highest lever I can pull on. But those who would greenwash or claim to be something that they're not can now be called to account. And do get called to account.
Bruce, there's a question actually from Bo. In California, how can construction projects use more sustainable concrete without increasing the cost too much? Do the structural engineers need to specify the concrete differently such that cure times are longer?
You can actually have lower carbon concrete that costs less. But to unpack that would take me a few minutes. I just finished making a 14-minute video on exactly this subject. So look at that website you see at the bottom of the screen, buildwell.site. Go there and there's a video on low carbon concrete that answers that question in some detail. How great is that? I've got a video about it.
Amazing.
The short answer is it can be less expensive. It can be more expensive. Generally, in construction, we're in a hurry because time is money, and the more we're in a hurry, the higher our emissions are. That's just what I see everywhere. Certainly with concrete. If you can give concrete more time to cure, you're not in such a hurry for it to get strong. You can use less cement and have a lower footprint. And cement's the most expensive part of the concrete, so you can have cheaper concrete.
I guess I have a question. What do you think it is the biggest hindrance of sort of shifting the regular materials for building? You already spoke to this a little bit. Is it sort of a combination of consumers and policies, or because I know technology is there, it's more like getting people to do mass scale change on materials. But I was wondering if you had any quick thoughts on that at least.
Well, that's the $1,000,000 question, isn't it?
Okay.
I actually do know the answer, but I'm not at liberty to tell you, Lindsay. So.
Okay.
No, that's it, right? When we're all dumbfounded, like in our country, in America, maybe some people here aren't U.S. citizens, but a large part of this country is convinced that climate change is a hoax, and large parts of other countries too. And they're digging in their heels, and this bizarre evolution of the internet, they only read news sources that agree with them, and so they just, how do you change that? This is pulling on a lever much higher than I know how to reach. I mean, we all think about this. How to, like, what? It is getting hotter. The thermometer says getting hotter. The CO2 is building up on a steady curve. How about Mauna Kea? We're getting the storm events. The sea level is coming up. It's all right there in front of us. And we don't act. We don't respond. That is the tragedy, the heart-rending tragedy that if somebody out there knows that little flick of the wrist that's going to change all this. If everybody were aware, let's just keep it to the construction industry. We don't drive ourselves crazy, but it's the same thing. If everybody were just thinking about carbon all the time on a job site, in a design office, in a product manufacturing, we're just thinking about it, like, okay, how much could we reduce our emissions? Maybe could we even store concrete in what we're doing right here, right now? If people just were thinking that way, we would start doing it. It would happen instantly. It can change in it. When Franklin Roosevelt was president in the middle of World War II, Albert Einstein sent him a letter saying, well, it's theoretically possible to build a weapon that would basically end the war. It'd be a nasty weapon, but you could do it. And he was persuaded, and he signed an executive order that launched the Manhattan Project. And there's a good movie about it now. Oppenheimer, you've all heard of it. The thing is that it was only 2.5 years between him signing that order and that first atomic explosion in the New Mexico desert. 2.5 years. For better or for worse. But there it was. When we put our minds to something, and this was a bunch of guys gathered from all over the world, didn't all speak English. There were no computers. They barely had telephones. This old boys ranch in New Mexico. And they figured out how to split the atom, and they did it. In other words, when we put our minds to something, we do it. We can get it done. We're badass. For better or for worse. So if by some magic we could all align, I think we'll just solve climate change. We'll pull carbon out of the air, and we'll realign all of our industry and the way we do things. But how do we get ourselves to that point? That's the rub.
Great. I think if we don't have any more questions, I might just ask one last question and then we can wrap up. I know you've got your book here, Bruce. Are there any other resources beyond, of course, the BDLA and BuildWell, where you would recommend that people go to see more information about embodied carbon and some of the topics that you discussed here?
Oh yeah, very much the nexus in North America, in many ways globally, for climate-friendly building and embodying carbon in building and carbon in general in buildings is the Carbon Leadership Forum out of Seattle. CLF. Just Google Carbon Leadership Forum if you're not already familiar. It was started by Kate Simonen, who's both an architect and a structural engineer and a wonderful human being. Started it. And they've grown into quite an organization doing a lot of good research, publishing a lot of useful information. I'm working with them. We're going to be doing some video. So that's the answer to that question. The single, there's others too. There's RMI, Rocky Mountain Institute, doing a lot of great stuff. RMI, the buildings group, and Architecture 2030. Sort of those three are the big ones. Carbon Leadership Forum, RMI, and Architecture 2030.
Great.
And there's many more doing great work, but
There is one more question here. Are mass timber buildings economical and good for the environment for projects in California? Seems like the project needs to be close to the source of the wood.
a lot of angles on that question. I haven't kept up actually. I know that somebody was working on making a mass timber lumber plant using the beetle kill pine, which is everywhere in the Sierras now. You know, and people have been working on that for a while, and I haven't stayed in touch to see what the status of that is. But there are people who are working on, because there's forests all over Western North America that have been decimated by the beetle kill pine. But the lumber is still perfectly useful for mass timber. And there are mass timber operations in Oregon that, and maybe in California now, that only use FSC certified lumber. And transporting from Oregon to California is not that big of a deal. It's not adding that much to your carbon footprint. So the answer is yes, you can. You just have to, pardon me, ask for the EPD. Again, you can ask for the EPD and see what your carbon footprint is. And if they say, well, we buy all of our lumber from an FSC certified forester, that's kind of all you need to know.
Great. All right, I think we'll wrap up there. Just before we let you all go, I did want to mention we have a few events coming up. So this webinar was actually one in a series of webinars we're doing. So we have one every month. The next one is coming up on March 14th at 11 a.m. Pacific time, and it's about gas stoves and indoor air quality. And we'll have researchers from Stanford and RMI joining us for that. The next one in April will be with the founder of the Building Decarbonization Coalition, and that'll be on April 12th at 11 a.m. So there's more information for both of those, and the rest are upcoming events on our website. And most exciting, we have our symposium coming up on March 8th. So that'll be a 3-hour event from 9 to 12 Pacific. And we'll have a number of speakers, including Kara Carmichael from the White House, as well as Panama Bartholomew, who is the founder of the Building Decarb Coalition, and a professor from MIT talking about some of her teaching methods. So we've got lots of exciting stuff coming up. So I'd encourage you to take a look at our website, sign up for some of those events, and hopefully we'll see you all again soon. And thank you again so much to Bruce for joining us today. That was really interesting, and I hope everyone enjoyed. Take care.
Thank you, Bruce.
Thank you all.